I think we're good to go. So thank you for being here. And my name is Jessica Gullbrand, and I will be presenting the Immersion fluid specification. Unfortunately, my co-authors, Sandeep Ahuja and Chang, weren't able to come here to OCP, so I will be giving this presentation. And we've heard about the fluid specification here throughout the different presentations today. But the outline of the agenda here is really to talk about, again, just reminding everyone what the fluid specification is about, and then talking about the fluid evaluation. So basically, since this was approved by the OCP, right, late last year, so December 2022, the fluid specification was approved, and I'll be talking about what we have done since then as well, and give an update of that. And that's part of the fluid evaluation. Then have a summary and call to action. So why did we generate the fluid specification to start with? Well, we have heard from several presenters today as well that there's a lot of immersion fluids on the market today, right? So how does a immersion customer or user select a specific immersion fluid? That's not an easy choice, right? And there's constantly new fluids in development as well. Well, one of the things, and I should say also, with having a lot of different options or a lot of immersion fluids on the market, makes it harder for an ecosystem really to set up around immersion as well. So what we were doing at Intel was saying, okay, let's look at it from the perspective of what does the IT requirement need from the immersion fluid. Let's make sure that, because one of the criteria, of course, of the immersion fluid is to make sure that you can get the properties out of it to support your IT equipment. And the parameters, the main parameters that are impacted by you immersing a system is the thermal cooling capability as well as the signal integrity. So that's why we were putting together the immersion fluid specification in order to provide basically requirements around what is it that the IT equipment need currently and also in the future for successful installations. And and again, just as a reminder, right, we did this in terms of determining the thermal and the signal integrity requirements. And instead of specifying each different parameter of the fluid properties, we looked at figure of merits instead. What is it that we need the fluid to do, right? So we generated 3 different fluid or figure of merits for single-phase immersion and 1 for 2-phase immersion. And for single-phase immersion, the first here, the figure of merit 1, is really based upon the Nusselt number of natural convection between 2 plates in a heat sink. And if we take away all the dimensions out of the Nusselt number, we end up with this expression, and that's the figure of merit 1. And it depends upon thermal conductivity, thermal expansion coefficient, specific heat, density, dynamic viscosity, right? So instead of specifying each of those parameters separately, we're putting them together in figure of merits. Then the second one, so the IT equipment won't just operate in natural convection, but also in forced convection. So the second figure of merit is based upon the Nusselt number for forced flow through pipes. And here again, if we take all the dimensions away out of the expression, we end up with similar, if I would say, thermal conductivity, density, specific heat, and that will give you the figure of merit 2. Figure of merit 3 is really related to pressure drop, meaning how much pump power do I really need to use in order to force the fluid, right? And if you're taking all parameters away that are not specifically related to the fluid, you end up with the dynamic viscosity. So that's the figure of merit 3. For the figure of merit 4, the definition of that is based upon the critical heat flux. So if you're taking a few constants away here, you end up with this expression that depends upon the density of the gas and the liquid, the surface stress, and so on, right? So you see the expression are up here, and more details, of course, is in the fluid specification. And for the signal integrity parameters, or the electrical parameters, were selected to specific values on those. And that's what we ended up with then, of generating in the fluid specification, generating a table of not only the figure of merits, right, but also the electrical parameters and other parameters. I won't go through this, and I'm not expecting you to read it either. It's the top green box there is related to the figure of merits that we just discussed, and the lower green box is related to the electrical parameters. But you can find the detailed information in the base specification for immersion fluids, which is, of course, available on the contribution webpage. Okay, so that's where we're at. That's what we generated, and this was then heavily vetted as well within the OCP community. So I also want to do a quick shout out to the OCP immersion community for all the valuable feedback that was incorporated before this specification was approved and now available. So but what we should keep in mind here, right? So really saying, okay, we got an immersion fluid specification, that's great, that's a first step, but that's not your only criteria when you're selecting an immersion fluid, right? It's the first criteria, but there's a lot of other options also that you need to, and parameters to consider here. Which ones are those, right? And that's what we will be talking about in the next slides. And it's really coming back to the immersion fluid evaluation. So there's 6 different phases from an overall perspective here. And from phase 1, that's where the fluid specification is part of. I will talk through it. I will have a slide on each of these different phases afterwards. So I won't go into too much detail here, just talking from a high level that phase 1 is really the tank and CDU material compatibility. Phase 2 is package and system material compatibility. So now you start bringing in the IT equipment. Phase 3 is functional component, material compatibility of that. Functional component, when I say that, I mean systems like SSDs and DIMMs, right? So functional components. And phase 4 is system performance capability. So this is where it comes in. Okay, so how good does this immersion fluid now cool the high power components, as well as ensuring through signal integrity testing in order to make sure that the performance that you want that you're basically going to get that, right? Phase 5 is the reliability evaluation. We heard before lunch here about reliability as well, right? We all know that this is a big factor in immersion, and we need to establish what those test methodologies are as well, right, for reliability in the community in general. And then phase 6 is fluid qualification. So this is basically when we're saying that from an Intel perspective, we're also looking at including future products, right, in the last step here of evaluation. So jumping into then, before we go there, I should say that we're currently in phase 2. So from when it was approved, right, in December 2022 until now, so almost a year. We are currently in phase 2 of the evaluation. And I will go in, as I said, into more detail about where we are and what the different phases here mean. So phase 1, tank and CDU material compatibility. So this is where Intel, we sent out a request for information to fluid suppliers to solicit their interest, if they were interested in participating in this evaluation. And the fluid suppliers then responded back with potential or proposed fluids that were meeting the immersion fluid specification requirements. And we also asked the fluid suppliers to fill out the material compatibility list. So if you go into the material compatibility immersion document that was developed also within OCP, you will see that there are tables of different materials in there. So we asked them to fill that out so we could get a better understanding of the material compatibility of different fluids. So we got a lot of positive answers and many proposals on many different fluids as well. And sometimes the fluid suppliers responded, right, that, hey, we got several different fluids here that meets the requirements as well. So that was the first phase, and that's where we used the fluid specification in that. And here's a link also to the material compatibility white paper that the immersion community developed. So in summary, phase 1, request for information and fluids proposed by suppliers. Phase 2, which we're currently in, right? So this is where it comes into the package and system material compatibility. We have generated the documentation here for the test plan. And we also generated basically a bag of parts, a kit of different materials that are used on the IT equipment that we sent out to the fluid suppliers. And the fluid suppliers are currently performing material compatibility testing on this test kit using the OCP test methodology, also available in the previously mentioned document. And the test data will be reported back to Intel. And this is something that we're also working on from Intel's side of contributing down the line here more of the IT equipment materials to make sure that we can extend and expand on those material compatibility lists in the previously mentioned document. So phase 2, in summary, material compatibility of IT equipment materials. And that goes into phase 3, functional component material compatibility testing, right? So yep, we generated and documented the test plan here as well. We also generated the test kits, right? The bag of parts, again, of functional components, such as DIMMs, SSDs, PCIe, NIC cards, right? And so on. And then material compatibility of those components will be performed. After material compatibility testing, we will take those components and put them into an air-cooled servers to test different workloads and performances to make sure that there has been no impact to the performance capabilities of the functional components. And this is also something that we saw from the fluids and materials work group, something that Intel is also collaborating with in order to bring in what those test methodologies for functional components look like. So phase 3, summary, material compatibility and performance testing of IT functional components. Phase 4 is system performance capability. So here we start getting into the servers themselves, right? We have documented the test plan there. And this is really, again, it's focused on the thermal characterization and signal integrity characterization. And for thermals, we're focusing on the high power components, right, in both natural and forced convection. Goes back to the figure of merits as well, right, that we were talking about in the fluid specification. So we're looking at the cooling capability for varying power, fluid temperatures, and flow rates as well. And for the signal integrity, we heard a talk this morning from Kai Wang and Andy Young of where the largest challenges for signal integrity is that we see going forward. It's the PAM4 112 gig and PCIe 6 and high frequency DDR5. Test data here at this step will be collected at the time is equal to 0. So Intel is co-leading the signal integrity work group. Kai is doing that together, as I said, with Andy from Aspiritas. So phase 4, thermal and signal integrity characterization testing. That's a little bit more information about that. Phase 5, that's where the reliability evaluation comes in. So we're actually currently writing down the test plan here. That's the stage that we're in. And this is where we will be performing reliability testing for the whole system, the whole IT equipment, the whole server, as well as on a package level. So this will be specified, Intel-specified IT equipment, hardware, right? And we will be stressing the equipment over a longer period of time here. And the test data will be used to determine the reliability evaluation. So that's the 5th phase, right? Reliability evaluation of IT equipment, both package and system. Phase 6 is the fluid qualification. This test plan has not been written yet. This really will consist of analyzing all the data from all the other previous phases of phase 1 to 5. And Intel will here, the idea is to perform the qualification testing for future products, right? So the whole process of fluid evaluation will take a while with all these different phases. So if there's any materials that have been changed or any new products that's come up, that of course needs to be encompassed in this step. So that's the reason really for phase 6, fluid qualification by Intel to envelope new products. That comes in here. So in summary, after then the immersion fluid specification was generated and approved back in December 2022, we've used that in order to get through basically the first phase of providing thermal and SI requirements for current and future IT equipment in the first evaluation of immersion fluids, right? And and that's phase 1 out of 6 different phases. Phase 2 to 6 is covering the material compatibility, reliability, thermal, and SI capability. So we're continue to work with several different fluid suppliers, and evaluation is currently in phase 2. Which is material compatibility of IT equipment. So call to action is please come and join and collaborate with us in the cooling environments projects, and specifically within the immersion project, and participate in generating and propose sustainable immersion fluids, both for single phase and 2-phase. As I said, please come and work and participate in the fluids and materials work group, where we're planning on adding or contributing more material regarding material compatibility for IT equipment and functional server component compatibility and test methodologies. And last shout out here is industry needs to standardize around OCP compliant immersion fluids and start generating an immersion ready ecosystem. So thank you for your time.